So now let's cover some of the other things that we can do with the plot function, because this plot that we have right now is admittedly rather boring. It's not particularly interesting or nice looking. So let's add to it. The first thing that we can do is change the kind of style of the points that are being plotted and the colors. So if we have this plot function that we've been working with that produces this very simple scatter plot that we already have, what we can add is the PCH argument. If you pull up the help page for this, you'll be able to see that this argument controls the style of the point. There are a ton of different options with this. The default is, of course, PCH equals 1, which produces the plot that we already have. PCH equals 2. If we run that, we can now see that our plot has triangles instead of open circles. There are tons of different options here. You can scroll through the help files. You can Google to see all of the different PCH options that you have in R and see what you like best. And me personally, I tend to go for PCH 16 or 19, which produces filled-in circles. I think those are a little bit more neat looking. So that's how you can change the point styles for your plots. You can also add another argument that controls the color of the points. Let's say that instead of the default of black, I want to plot these points in red. I can do that by adding an argument COL. The COL argument, standing for color, takes there's a couple different options. You can specify the name of a color, and if it's a name, you have to put it in quotation marks. So I put red in quotes, and that will plot my points in red. If I do the same thing for blue, again, putting it in quotes, my points are now blue. This is kind of the most basic way to change the color in your plots. A pretty simple and straightforward way to spice things up a little bit. Now I want to show you that we can also add more arguments to control the axes and to add a title. So if you want to change the axis labels, right now it just says M on the y-axis and CFS on the x-axis. And if you don't actually access the help page for this data set, you won't know what those stand for. So we might want to be a little bit more specific, and we can do that using two arguments called xlab and ylab. The xlab argument stands for x-label, and this will allow you to specify on the x-axis a different label. So here I'm typing in core and flake scrapers, which is what CFS stands for, and doing xlab equals that. And now you can see that I've changed my x-axis label on our plot. It now says core and flake scrapers, just like I said. We can do the same thing on the y-axis using the ylab argument. M stands for microliths, and so if I do that, it now changes the y-axis label on the plot. Again, a very simple thing that you can do just to make things look a little bit more nice. If you wanted to then add an overall title to the plot, and this is not something I often do, but if you wanted to do it, you can use the main argument. Here, let's call it microliths and scrapers. So main equals microliths and scrapers. This will create an overall title for your plot that corresponds to that argument. So you've still got your y-axis, your x-axis labels, and now there's an overall title for the plot. This can be useful if you're generating a bunch of images and just quickly pulling them up and looking through them for whatever reason. Now, this plot that we've got here, I want to also show you that there are other things we can do. I'm just deleting the main title just to clean things up a little bit. If we wanted to change the color, now I've got the color specified as blue, which is just the word blue in quotation marks. But there's another way that we can handle colors, and this is called hex codes. I generally go for this approach when I'm making my plots, and there's a reason for this. Every color has a 6-digit hex code associated with it. This is based on color theory. We don't need to get into that, but you can Google it if you're interested. For example, the hex code for black is the pound sign, or the hashtag, 000000, 6 zeros. If I do that, our plot is now back to black. This hex code of 6 zeros preceded by a pound sign is equivalent to just saying black in this color argument. It produces the same outcome. The hex code for red is FF0000. If I do that, same thing as saying red in the color argument. Now, this seems like a more complicated way to just get these basic colors. But what's different about this approach is that if you want something other than basic colors, it makes it easier. Inevitably, I end up Googling hex code for whatever color you're interested in, because you can never remember these hex codes off the top of your head. But the really useful aspect of hex codes, in my mind, is not just getting a little bit more unusual colors, but also making your colors transparent. And this can really make your figures pop. So here, if I add to the end of this hex code for red, which is FF0000, if I add another 2 digits, let's say 50, what I'm saying is I want red, but I want it to be 50% transparent. So adding those extra 2 digits controls transparency in a hex code by percentage. Now if I run this, you can see that my plot, the color is now transparent. Some of these reds are very pale and some of them are darker. The reason that some are darker is because there are multiple points on top of each other here. That's something that we couldn't see before when everything is just red, because multiple points are getting put on top of each other and they're just covering each other up. They're just masking each other. But whenever we make our points transparent, we can actually see a little bit more clearly that those that are darker have more points on top of each other. So there's actually a lot more data here than we think there is based on that simple plot that isn't colored transparently. So this, using hex codes to control your colors, is a really useful trick that you can do.